Hi, grade 11s. Welcome to another series of iCampSA lessons. If you are seeing this on YouTube, please make sure that you subscribe, like, comment, and share our video. So today we'll be covering your error real proof, right? We'll cover both the cases, which is your acute angle or for acute angle triangle and for obtuse angle triangle, right? In all our concepts, which is your sine rule, you will have your acute obtuse angle triangle. Cosine rule, you will also have your acute and obtuse angle triangle, and the same is true for area rule. You will have your acute and obtuse angle triangle, right? So you need to know all these cases for all the concepts. They are very important. The examiner can decide to put any of these concepts and you should be able to answer them precisely. Great. So let's get into it, right? So we are going to do the area rule for the acute angle triangle, right? So let's just draw our triangle, which will be the acute angle triangle. So you have A, B, C. Right. Remember how we name our sides, right? We name our sides. So always the side that is opposite angle A. So the side that is opposite angle A will be side A, right? And the side opposite angle B will be what? Will be side B. And the side opposite angle C will be what? Will be side C. So we'll go ahead and label our sides, right? We'll have A, we'll have B, and then we are going to have C, right? So here's an interesting thing. When we do our area rule, right? So the area rule is precisely simple, right? So it says that the area of triangle ABC, right? The area of angle triangle ABC, right? It's going to be half, right? It's going to be half AB, right? Which is, it's going to be half AB. So if it's half AB, it should also include what? This angle, right? So it's going to be two sides, right? And then angle between those two sides, right? So what I mean by that is the area of this triangle, right? It can be found by saying half, right? It's going to be half. In fact, let's just write all the possibilities here. So the first, it's gonna be, let's say, the area of triangle ABC, right? It's going to be half, right? If it's half, half A times B, and then it's going to be your sine angle C. So it's going to be this side and this including this angle, right? And then let's just try to highlight it so that it can be seen, right? And then now you are going to have, it's going to be this angle, right? This angle. And then let's write for another scenario, right? Let's just write all the possibilities. So I'm just gonna take the same, copy it, and then I'll just put it here, right? And then now the other possibility is, now if I say the area of, I can also write this as 2, come on, right? Which means that the area of triangle ABC can also be written as 1/2 what AC, let's just say A times C sine of angle B, right? So this is very important. So let's just put it like this. That's this side and the included angle and the angle in between those two sides. Right, and then now let's write the third one, the third and the last scenario. Right, so we can choose any to prove by, right? So these I'm just giving you a basic idea of how these rules work or how they work, right? You should be able to work with them. So now, okay, so now the last being 3, it's still the area of triangle ABC, which is gonna be half, right? So now it's gonna be half. Let's just say now it's gonna be half this and that. So it's gonna be half it's gonna be half B times C sine of what? Sine of angle A. Sine of angle A. Great. Right. So these are all the scenarios or the possibilities when we talk about these areas, right? These are all the possibilities when we talk about the area rule for triangles. These are all the possibilities. It's always the two sides, including the angle in between those sides, right? Great. So we can always choose any, right? We can always choose any. So for the purposes of this video, let's just take the first one, right? Let's just take the first one. Right, we need to prove the area rule, so I'll just take this, right, and then I'll come here. So this is what we are required to prove, right? So this is what we are required to prove, and then we are going to use this triangle. So right, so let's just take this here, and this is what we are required to prove. Great. So now let's go ahead and try to prove that, right? Let's go ahead and try to prove that. So you have A, right? So now the first thing that we are going to do is we are going to construct a perpendicular line, right? We are going to construct a perpendicular line, and that line will be called H, and it will divide this, and then we'll have triangle here, and then we can call this D, right? Great. So now what I can do is I will say the area of triangle, right? The area of triangle ABC, right? This is the area of this triangle, right? The area of this triangle, right? So I'm going to have in triangle ABC, right? So the area of triangle ABC is going to be given by 1/2, right? Base times your perpendicular height, right? I'm just using the normal area area of a triangle rule, right? So now I'm going to have 1 over 2. What is my base? Base is this entire side, which is A, right? So my base is going to be A, right? And then what is my perpendicular height? Perpendicular height, it's just H, right? It's just H. So now what I'm going to do, right, I want to write H in terms of sine angle C, right? I already have A, which is part of what I'm required to prove, but now I need B sine C, right? So the way that I'm going to do that is by using my trigonometric ratios, right? So now I will focus on, I will just come and say in triangle, right? Now I'm going to focus on this triangle. Remember, I want to deal with C. So this is where C is. So this is the triangle that I'm going to deal with, right? So this is the triangle that I'm going to deal with, which is triangle ADC. So I'm going to say in triangle ADC. Right, now I'm going to use my trigonometric ratios, right? So I'm going to have here my sine, right? Sine of angle C. So this is going to be sine of angle C is going to be opposite over hypotenuse. So this is going to be H over B, right? This is H over B. And then I can multiply by B both sides, B by both on both sides. And then this and that will cancel, and then I will be left with H is equals to my B sine of angle C, right? And then I can call this, I can literally call this equation 1, and then this I'll call it equation 2. And then from here I'm just going to substitute equation 2 right into equation 1 because I have something in common, right? There is a H in both equations, so this is the H and then this is the H, right? So this is what I'm going to substitute. Now the final thing that I'm going to have is the area of triangle ABC is 1 over 2, right, times A, and then we substitute into, so where we see H, right, we are going to substitute B sine C. So it's going to be now B sine of angle C, right? So this is how we prove this, right? So this is how we prove. It's fairly simple and straightforward. It's fairly simple and straightforward, and you can prove it the same way we do for all the other angles. So if you want to prove it using this side, you can also, if you want to prove number 2, you can also do it, but we chose this, right? But you can also test yourself to do this or this way, right? Great. But any it should be able to apply the same principle and still be successful in doing that, right? So now what I'm going to do now, I'm going to do the same thing but for obtuse-angled triangle, right? I'm going to do the same thing but for obtuse-angled triangle. So it's still the area rule, right? It's still the area rule, so I'm still on area rule, right? But now I'm focusing on obtuse-angled triangle. Remember, the first one was your acute-angled triangles, right? This is your acute-angled triangle. This was the first one, right? So now I'm gonna do it for obtuse-angled triangle, right? So let me just draw my triangle here, right? And then I will have my A, I will have my B, I will have my C, right? So these principles, right? These principles, they still apply, right? Doesn't matter. Just because now it's an acute angle, it doesn't mean that, just because it's an obtuse angle doesn't mean that these principles do not apply. So they still apply, right? So we are going to prove it using pretty much the same way, but I think the easiest would be if we say we use this as an included angle, right? So this means that it's going to be this side and this side times this angle. Great. So let's go ahead and name our sides. So this is going to be side A, this is going to be side C, and this is going to be side B, right? So now I'm going to use, I'm just gonna use this one because it's fairly the simplest one. So my area of triangle, so what I'm required to prove, what I'm gonna be required to prove is that the area of triangle ABC is gonna be equals to 1 over 2 A times C sine of angle B, right? So this is what I'm gonna be required to prove, right? This means this is the angle that I'm gonna be focusing on. This is what I'm gonna be trying to prove, right? Great. So now let's go ahead and see how we can best do that, right? So the first thing, so what I'll just do, I'll just copy the same thing here, and then I'm going to construct a perpendicular height. That's very important. Now I'm just going to construct a perpendicular height. Do I have to erase this? No, I don't have to erase it. So I still have my B. So now I'm constructing my perpendicular height. Let's just use red. So now I'm going to construct my perpendicular height. This is going to be H, right? This is going to be H, and if this angle is angle C, then it means that this angle is going to be 180 minus C, right? And then we can call this point D. Let's just write this. Okay, it's always good to show that it was a constructed line by doing dashes. Great. So now this is just C. Great. So now what I'm going to do is I will just say the area of triangle ABC, right? This is this triangle, right? It's the area of this triangle. So I am going to say in triangle AB, I'm going to say in triangle ABD, right? So the area of triangle ABC, it's going to be half times base times your perpendicular height, right? So in this case, it's going to be 1 over 2 times, what is my base? My base is A, right? And then what is my perpendicular height? It's just H, the red H, right? So now I need to write H in terms of sine, right? Now what I need to do, I need to write H in terms of sine. Great. So what I am going to do now is, in order for me to do that, right, I am going to look at now triangle ABD. which is still in the same triangle. Now, which is this one, triangle ABD, right? Triangle ABD, and we are focusing on sine B. Right, so in triangle ABD, the same way, so I am going to have the sine of angle B is going to be equals to the opposite side over the hypotenuse, so the opposite being h, and then the hypotenuse being small letter c. So I can just multiply by c, multiply by c, so c and c will cancel, so I'll be left with h is equals to c sine of angle B, right? And then I can call this equation 2, right? And then this will be my equation 1, right? And then now I can simply substitute 2 into 1, right? Why? Because I have something in common, right? I have h, and then I also have h here, right? So now, therefore, the area of triangle ABC is going to be equal to my 1 over 2. It's going to be equals to my 1 over 2 times A times, in space of h I put c sine B, so it's going to be c sine angle B, right? So now I have proven, right? So now I have proven that rule, right? So you can do it for any scenario, but basically this is how we do it. This is the concept, fairly simple and fairly relatively easy. You should be able to do this without much of a hassle, right? Now, thank you for tuning in. If you have not subscribed, please make sure you subscribe. If you are seeing this on YouTube, please make sure that you subscribe, comment, like, and share the video. If you are a member of us, part of the iCamp lessons, thank you for tuning in until now. See you on another video. Thank you.